Good day, everyone. Welcome to the first talk of the CUDOS Entrepreneurship Seminar Series. So really this idea for this seminar series developed out of the CUDOS workshop, well, almost 2 years ago now, where a lot of the students said we want to hear a little bit more about things which are useful for careers outside of academia, not just get mentoring in academia. And so also the new CUDOS has a lot more focus on creating new businesses. It's we want to have a real impact in the real world, except not just in science, but really create spin-offs. And so Simon suggested we have this fortnightly seminar series to really get this idea of entrepreneurship into people's heads. So today is the first talk. I have the honor of introducing Dr. Simon Poole, who is really one of Australia's leading entrepreneurs in photonics and optics. What are you looking at?
The leading.
The leading, okay.
The leading.
I've got a story about that.
Well, the leading, a leading. He was originally an academic, like us, or most of us here. Was part of the developers of the ATVAS in Southampton, an inventors which really is one of the main technologies of today's telecommunication networks, and has really worked for 30 years in optical communications. He's been involved in several startups, and 3 of these we'll be talking about today. That's Index in Ghana and the Wave Shaper startup in Finisa. He's the Sydney Entrepreneur of the Year 2010. Well, we see those, the Innovation Hero 2010 and the Entrepreneur of the Year from the PSC Foundation 2011. Also, I think the Optical Communications Group, which is he's heading, just got the engineering, what is it called?
The Brentfield Award.
Brentfield Award of Engineering.
Which is sort of the gold logie of the engineering profession.
All right, so without further ado, Simon.
Thank you very much, Jochen. Thank you everybody for coming. It's great to see so many people interested in this whole concept of entrepreneurism and the idea of actually there is a life beyond the university. There is a life outside the university, so we could hopefully by come to some of these lectures you'll get some idea of what that life can be like. Certainly at the sort of startups. There's a lot of talk in sort of policy circles and in government and around the place about the importance of innovation. And I think innovation is a critical part of any component, any development. But I think what a lot of it misses is not just the innovation, which is the creation of new ideas, it's the translation of those into practice. The taking those ideas and basically making money out of them. That's the sort of the way that I view entrepreneurship. It's a way of crystallising innovation and taking it to the marketplace. And my marketplace is the photonics telecommunications industry, and many other marketplaces. And we'll address some of those during this series that we have over the next few weeks. We've got a range of different people coming to talk about different aspects of this, which will hopefully give you a bit of a flavour. We're trying this out, as Jochen said, just for a few, I think it's 4 or 5 lectures to start with, see how it goes, and then if it's going the right way, we'll get some different people, a bunch of other people lined up from some large companies and international companies as well. And we'll see how this all plays out. But today, I'm really here to talk about 3 startups that I've been involved with. We saw in that first slide, there's a bunch of companies. I've been doing startups since 1981. When I started my PhD, the first week of my PhD, I joined a startup at Southampton University called York Technology. I was their 7th employee, and I basically worked with them all the way through my PhD. was involved in another startup. They did called York SMP, which took some of my PhD research for specialty optical fibres and started selling some of that. So I've been sort of doing startups for a long time. I like doing startups. They're fun. Being a big company is not necessarily quite as much fun. So I'm going to talk about startups. I'm going to start off talking about telecoms industry, just to make sure that everybody knows where we're sitting in this. Now, most of the audience here, I suspect, are physicists. Most people have some exposure to the telecoms industry. I just want to make pretty clear where we sit and how this all fits together. And I'll talk about 3 different companies and different ways that we started. First one will be Index, which we basically bootstrapped out of the photonic CRC back in the mid-90s. Then I'll talk a bit about Engana, the company is now Finisar Australia, which we basically funded by raising money from venture capital. And then I'll talk about the Waveshaper group, the Waveshaper active I'm currently running, and it's slightly bigger compared to the optical instrumentation group, which basically is an internal startup within Finisar, where we sort of created a little standalone business entity, and we're running it like a startup. The pressures and the differences that involves compared to the other 2 ideas. So let's start off with structure. Let's make sure we understand where we're sitting. What we have, I can't stand in one place. So, to start off, the most important people in all this are the people who pay the money in the end. That's you guys. You're the people who create jobs for all of us people and support, particularly the people under the age of about 30, because you use an awful lot more video than us old players do. Okay? It's basically people streaming vast amounts of video to their homes, their computers, and as we'll see, to their mobiles, that creates this whole industry that sits underneath and supports that industry. It's that growth of bandwidth up here, and bandwidth consumers, that gives people like me and ultimately supports your research in this space. We have people who deliver bandwidth, the telcos, the carriers, people like Telstra, Optus, AT&T, Verizon, NTT, KDD, NBN is the big one that's the new kid on the block here. They basically provide bandwidth to the user. They do that using equipment from what I call bandwidth supply. So I always think in terms of bandwidth use, the bandwidth is the group. And this is companies like Fujitsu, Cisco, Huawei, Alcatel, Lucent, ZTE. There's about a dozen major and a dozen small.
Shouldn't there be another layer in there, like the Google sort of thing, like the service, the actual service?
Now, these guys deliver the bandwidth. Google doesn't. They just take a free ride over the back of these guys.
Right.
Net neutrality isn't net neutrality. It's about making the guys with the content get it there for free. So this is the value chain of bandwidth delivery. Not the value chain for selling content and services. So we then have this equipment manufacturing. Down at the bottom, what I call the bandwidth enablers. This is the guys who do the component and subsystems, so the optical component guys. Companies like my own company, Finisar, JDSU, Opnext, and so on. I've basically spent most of my life living at the bottom of this food chain. So I sort of sit down here with the people who, as I say, enable bandwidth, because we create the components that allow these guys to build their systems. And the great thing about this, as I said, is that the internet is basically still growing. People back in the 90s said it's doubling every 3 months or whatever. That was crap. It doubled once for 3 months, then gave away. It's too hard. But what we're seeing is still something that's growing at around about 30 to 40% a year. Now, there's not many industries that grow 30 to 40% a year for 20 years. That's an amazing sort of growth rate that comes from bandwidth consumption on the internet. And it's all driven by this consumer internet. Consumer managed IP, by the way, is cable TV. So this is all basically TV that's being driven by video to the consumer. The interesting thing about this, even 3 years from now, only 4% of the internet bandwidth is going to mobiles. Everybody says the mobile explosion is driving everything. It's not. It's a very, very small fraction. It's an important fraction. It's growing very fast, but it's still a very small fraction. It's still basically fixed line connection was doing it. And I noticed, I started this with my kids, you know, we sit at home, I've got my iPad, they've got their computers, we're all watching videos and we're streaming another video on the TV, so we've got 4 videos going at once, all to these bloody computers sitting on the same sofa. It's ridiculous. But that's what drives this, is multi-screen usage of video. And the thing that makes this possible means that I and my kids can sit there and watch 4 videos at once in HD, streaming through my network, is the fact that it's much cheaper than it used to be to send data down a file. Okay? So what has happened is that basically the cost of sending data has dropped several orders of magnitude over the last couple of decades. It continues to do so. Basically, this curve comes down at somewhere around about 15 to 20% a year drop in the cost of sending data. Continues and continues and continues. We see that in our business. Every year we have to reduce our prices for the same product by 15 to 20%, which sounds, that's okay. If you do that for 8 years, you start with some $10,000, you get to $700,000. It becomes really painful. This is all driven by the development of optical components. The introduction of the erbium fiber amplifier, the introduction of wavelength division multiplexing, the ability to drive at 10 gigs or 40 gigs or 100 gigs, all driven by components. Not by new system advances, not by new bandwidth management or billing systems, all driven by the ability of optical components. Basically, the things that some of you guys are researching are what drives this. We make things better, faster, cheaper. It's almost like the Olympics of science. Better, faster, cheaper. That's the mantra that we have in the component space. So the companies that I'm going to talk about all work in this component space have all been contributing down into this level. So I'll start off by talking about Index. Okay, Index was a spin-off from the Australian Photonics Cooperative Research Centre. This was sort of a precursor to CUDOS. A number of the people sitting in this room were involved in the Photonics CRC during its time. It started back in 1991. And ran for about, when did it finish, Simon? 10 years? 2006. 2006 it finally collapsed. Under the weight of its accumulated paperwork. So I was the director of the Sydney node of the CRC. Okay, the CRC had a node in Canberra, a node in Melbourne, a node in Sydney. I was the Sydney director of that, running what was then the OFTC, Sydney University. There was a group at USW. CSIRO, I think as well, Chris, from memory, one of your guys, Kin was in that. And that was the group in Sydney. And one of the things about the CRC was that one of the stated aims was that the goal of the CRC is to create commercial outcomes. That was one of the stated upfront aims. It wasn't about pure science, it wasn't about great research, it was about good research. Commercial outcomes were a very important part of the whole way to set that thing up. So I basically set up this company Index. It wasn't intended to be set up as a company. I didn't intend to go out and set up a company. I actually started selling some of the optical fibre that we made in the OFTC. Built up a business selling about $250,000 worth of fibre a year out of the research group to companies in the US. We've got to design some products and we do some fairly serious volumes. The university was getting totally did like the liability that was getting associated with it by me selling fibre. I'd be given the okay to sell fibre to research groups, and I finished up selling to companies because there's more money in it. And we used that money to basically fund the research. We were pulling in $250,000 a year of research funding by selling fibre. It was a really good feedback. And then I was looking for the next thing. How do we create some more money? How do we get more stuff out into the marketplace? So I thought fibre brag gratings, we started research on these in 1991. They were still fairly new technology at that time, so there's still some good research to do. And by 1994, we had some really good grading lighting technology. Basically, we sort of sorted that part of it out, and we started looking at the problem of packaging gratings. Basically, how do you make these gratings temperature insensitive? How do you make them so when you pull on them they don't change? How do you package up so these things stay where they are when you make them? We nailed that problem as well. And then I basically spent 18 months taking this idea to all the industry that I could find in the optical space. There was a lot more in Australia at the time, saying, who wants to take this technology and commercialise it? Who wants, we've got this, it works, there's a market for it, who wants it? And I think we must have pitched to about 20 different companies at the time. And not a single one wanted a bar of it. Nobody wanted to touch it. I didn't want to leave the university. I had a great time. I was around a great research group, had funding for whatever, and was doing some really fun stuff. But nobody wanted to take this technology, and I thought there was a real opportunity to do something with this. So we actually finished up doing a startup. We borrowed $10,000 from the university, or CRC to be precise, in September 1995. I basically stepped down as director of the TCM. Simon, did you take over at that point? Yes.
Pretty much part of it, but Ian Bassett formally took over, I think, from
That's right, yes. So Simon was there, and he was sort of, thankfully, he managed to pick up the mess that I left behind. And I basically started with 3 students, one guy walked off the street, and myself, to do a company to try and make fibre-grade gratings. The guy who walked off the street is actually a guy called John Borman, who is still with me now, 15 years later. He's the most fantastic manufacturing guy I've ever met. He was one of the reasons this company was successful. Not because we have great technology, we have really good people to take that technology and turn it into product and be able to manufacture it. So we started with this loan, and then I went out and got an order. We hadn't actually got a product at this stage, but I went out and sold $30,000 worth of fibre-grade gratings to a company called Mel's Greer, who many of you may know from being a supplier of components into labs. At the time they were trying to break into the fibre optics space, so I managed to persuade them that they need to have fibre-grade gratings in their catalogue, and they said, okay, we'll buy 30 of these at $1,000 each. Got an order, then we didn't have a product, we had to go and actually develop this product, we had just lab type things. So we finished up developing the product basically evenings and weekends using the research equipment. So we used the research lasers and the workshops, and so we got access to the lasers when the students had finished playing with it during the day. We could then come in and write gradings with it, and we had weekends as well to do the grading writing. So that's what we did. We learned how to turn this sort of crazy lab prototype into a product that was slightly manufacturable. Learned how to write gradings and make gradings reproducible, which is not something that universities really worry about. As long as they get one that works, they can publish it and move on. Hard problems to make these things over and over again. So we did that, and we worked evenings, nights, whatever we needed to do, and started to get some traction in the market. And then about towards the end of 1996, we were just trundling along. We'd started out to pay salaries, because one of the guys had got married, so we started to pay him some money. The rest of us were pretty much working for nothing, and we hoped that we'd get through, but it was a bit tricky for a while. I'll come on to that in a second. And we basically then got lucky. We got into bed with a company called Fujitsu, who are a very large Japanese manufacturer of computers, communications equipment, all sorts of stuff. They chose our little company, which at the time was 6 people, working out of, by this time we managed to get borrow some more money, get some equipment of our own. We're working basically out of the technology department. We were about 3 labs in the technology department. They came down and we persuaded them that they could base their next submarine communication system on our little fibre gratings. This was a system called CUDOS. It runs from Japan, down through Asia, around the bottom of India, up through the Red Sea, through the Mediterranean, up to the UK. So it's SE Southeast Asia, SEA Southeast Asia, ME Middle East, and WE Western Europe, CBP3. Fujitsu were building half, Alcatel were building half. And we somehow, I have no idea how to actually do this, managed to persuade them that this little 6-person startup could actually create these gradings, which had to have what's called a fit rate of 0.1, which means that one of them has to allow, you'd have to have one failure every 10 to the 10 hours. which is something like a failure every 27,000 years or something. So this was a time when fibre brake range was still a lab curiosity. There wasn't really a global market for these things. So we had to prove that these things would maintain their properties for that long, that they wouldn't break, that these things would keep working. And we managed to persuade them to basically, that we knew what we were doing well enough by some very smart footwork and also some very smart people. People who understood the chemistry of grading defects, at least to the level it was in those days, who understood mechanical engineering, understood fibres. We put together a pretty good story about what was happening. And we persuaded these guys, Fujitsu, that yes, we can do this. We actually had them coming down to do the audit, which was very funny. They had to come down and do a quality audit of us. We had 3 rooms. Okay, we had the offices, we had 2 production rooms, and a sort of robing room at the front, and another room, a sort of corridor between the 2 offices at the back. So we had to basically show these guys that we were a real company, that we had enough people, we had enough resources. So we arranged a tour. We took them to the first room, which is the grading grinding room, and then the second room, which is the grading packaging room. So we had the grading grinding room, which we had 3 people in it, and then we took them out the back door whilst the guy through the back corridor into the grading packaging room, while the 3 guys in the grading grinding room went through the front door pretending to be doing the packaging. But because they had masks and gowns and things on, you couldn't tell who was inside. So we persuaded Fujitsu we were slightly larger than we were. And then, of course, when they came out of the packaging, there was the sort of shipping and final measurements area, and the guys that got out of their money said to go work. So it looked like we were about a 15-20 person company, was 5. Because we were just all moving into different. I was the only one who followed. I was actually with them the whole time. I don't know who it was. As I was much taller than anybody else, that didn't their giveaway. So we managed to persuade them to do that. So we got an order for $1 million worth of fibre gratings, deliverable over a 12-month period. And that's all very well and good, but then we had to somehow find the money to buy all the bits to build all those gratings. You know, then we didn't get paid until we delivered, but we had to buy lots of specialty fibre. We had to buy lots of packages, which weren't cheap. Packages were about $1,000 to buy each. We sold them for $5,000, so the margins were good. But we had basically to find, $250,000 worth of cash, which we didn't have. We were living hand to mouth on monthly Tuesdays with several researchers. And so once we got them over the line, they'd signed the contract saying that we got the order. Here you go, guys, off you go. Here's the delivery schedule. I then had to fly up to Japan and say, sorry, can't do it. We haven't got any money. We're going to have to stop doing your work and just carry on doing our old work, so I can't pay summons. Unless you, Fujitsu-san, can lend us or give us $300,000 by the end of the month. Because we can't pay the rent, we can't pay the salaries, we've got to do this stuff. And actually, they bought it. They said, yes, no problem. You can have $300,000. We will also help you with, we've got some technology in laser welding. We think will be really handy for you guys. So they basically, we took that technology and transferred some laser welding technology into us, which was great. They didn't actually give us the $300,000. What they did is they told our distributor in Japan to lend us that money. Not Fujitsu, no, they're a $100 billion a year company. This little tiny distributor is the way the Japanese system works. The big guys lean on the little guys and they do their bidding. And basically this company, Rikkei, had to lend us the money, basically prepayment of the purchase order. They would get their money from Fujitsu eventually, so Fujitsu guaranteed them. Cash came from the distributor. They paid up front, they paid we got the technology transfer in, we delivered those gratings. We delivered the last one on the 6th of December 1996, and then on the 6th December, then the 11th of December, I think it was, we signed basically the final deal to sell the company. So at the same time we were making these grades, we got up to about 10 people. I was selling the company with a guy called Richie to Uniphase. Uniphase, the company came Janius Uniphase, now one of the biggest players in the game. At the time there were about 600 people. So we were the third or fourth acquisition. They eventually became 30,000 people about 3 years later. So we sold this for 8 million. That was a really stressful period of trying to complete this order. The interesting thing about the submarine system is that you have to deliver as they're building the cable. You have these things all have to come together to build these repeaters which go into this big cable which goes to a huge drum on shore. And then when it's all built, they just pull it off again onto a ship and then wait. So you have to have the Iranians come in whenever they want one of these generators. So the timing constraints that we had for delivery were absolutely horrendous. We actually absolutely had to meet one of these deadlines, or their whole production line stopped. Because it's a continuous process, they couldn't sort of wait, and then we got them, they could fit them back in later. Everything had to come together at once. It was really, really stressful. But we sold the company for 8 million. We thought that was great. The company was started off from nothing with a $10,000 loan. We sold it for 8 million. That money was then taken by the CRC and used to fund the start of the whole Redfern group of companies. The staff in there, we got some bonuses for doing that, but the company was 100% owned by the university, the CRC at the time. We didn't own any of it. That's the way we had got the loan into it, that's the way we had set up the technology. We had no money, we couldn't afford to sort of start the company our own. Then we went and started to grow that company. We started to grow, there's a number of people in this room who worked for that company at various stages. We grew like crazy. We reached peak revenue of about 150 million a year of exports. All of this was export. In 2001, about 330 staff. This was up in North Ryde. It was a massive organisation. And then 2 years later, it was all shut down. So we went from like 6 people to 330 back to 0 in about 45 years. It was a really interesting ride. Speaking of Dolly next year, it was really interesting stuff. Chris is only 37, he just looks like that because he was part of that ride. Same with Eric, he was in his teens when I first met him, he was 10 years ago. It was an incredible journey, but unfortunately, when the telecom bubble burst, it went. But that was an interesting story of how to do it from a startup. I actually left around about here. I was basically burnt out at this time. I sort of had one nervous breakdown and we just completed that part of it and I was totally wiped. In '98 I spent 4 months basically off work because of the stresses of the previous 2 or 3 years trying to get this thing together. I worked my way back into the company and was technical director through until 2001 and then I basically left. I've done it, been in this company for 6 years, I've done everything I could possibly do, I need to go and lie down and on a break for 6 months. So that's what I did, I went and lay down in a dark room, did a little bit of consulting just to sort of prove I still existed, and swore that I would never, ever, ever, ever do another startup because it's too bloody hard and too painful and life is too short. So instead of that I went and did that startup. This is a company called Engana. Engana was founded in 2001 by myself and a guy called Steve Friskin to do intelligent optical subsystems for reconfigurable optical networks. So fibre gratings are great for fixed networks. They're lousy for tuning, but you can use them for selecting fixed wavelengths. We sat down with Engana at the start. Steve and I sat down at his dinner table, some good red wines in front of us, and said, okay, if we're going to do another company, big if, what would it be and what would it address? We had no technology. We sat and said, where's the market? What's the optical communications market look like 5, 7, 10 years from now? And the one word we kept coming back to was reconfigurable. The networks would not be fixed point to point, they'd be reconfigurable. So we basically created Engana on the basis that we wanted to play in reconfigurable optical networks. And from that premise, we then worked through what can Engana do, what could we do, what could we realistically expect to create. So, and this is from our VC presentation, the first VC presentation we did in January 2002, it's actually a slide from it. So what we did is basically said we need to put in intelligence with optics. So a lot more software, electronics around some optical component. We didn't know quite what it was going to be at that time. To provide reconfigurable functionality at a better price than you could do if you tried to build it all yourself. So we're trying to basically add value to optical components. And then we come up with a bunch of reasons why our customers would like it, the equipment manufacturers. Basically, it reduces their cost, increases their functionality, it reduces their time to market. Why the carriers like it, reducing the cost of building networks and reducing the cost of running a network. Instead of somebody having to go out with a truck and plug fibers from one place to another, they can do it remotely by software to route signal to different places. That's basically the argument that we used. That's still our thesis for the company 10 years later. So that's exactly what we do. It's the same, it's now Finisar, but this is basically the same thesis that we're still working. And this is what we make. We finished up making a thing called a wavelength selective switch. It's not what we started with. We started off with a tunable filter. We had to dream up something to get the VCs to invest in us. But we finished up making something totally different. Changed direction after 2 years. Basically, we got burned through $1.5 million, said, no, that's wrong. Sorry guys, we've made the wrong choice, we're not going to go that way instead of going that way. Sorry about that, wasted $1.5 million. But trust me, I'm an entrepreneur, I know what I'm doing. This is what we now make. We now build these down in Waterloo. Wavelength selective switch takes light on a common fibre, basically up to 100 WDM channels, and switches any one of those channels to any one of these output fibres using LCOS. Same stuff as the wave shapers. And that is now a 100 million plus a year business coming out of the water. We'll talk a little bit more about it in a second, but that's sort of where we're heading in this discussion. So how did we get from sitting around this guy's table with some good red wine and a bit of a hangout the next day to 100 million a year plus company? And that's the story I'm going to sort of tell for the next 10 minutes or so. This graph shows a very simple thing. This here is the quarterly revenues for optical communication, optical components. It's a function of which quarter we're in. So this is telecoms bubble 2001. This is where we started in Ghana. Just about the worst place you would think to start a company. The market's gone to hell in a handbasket. We didn't know what it looked like down here, whether it went like that, or whether it went like that, or whether it went like that. Our expectations it would do something like this. I couldn't believe it would go back up again. I couldn't believe it would go to zero because of the thesis of internet growth. So we started then, and we then raised over the next basically 15 months. We put together a Series A round. VCs talk about Series A, Series B, Series C. Series A is the first significant round of funding you get into a startup. You can do seed rounds and things before that. Series A is generally the first one. And we got together a Series A, 6.3 million, with those investors up there, TVP, Intel, Deutsche Bank, and our Japanese subsidiary Rika. Obviously, the fact they'd had tremendous money last time, they'd made like gangbusters out of Fujitsu on the margin, they sold the stuff to them, and they wanted a part of this from day one. So that was really good. The fact that Intel came in gave us some international credit, and then that brought in the other ones. Management also put some money. We put in about $700,000 as a management team. And we had a management team that had basically been through startups. Everybody in the company had been through at least one startup before. So it was a real team of people who had done this, grown businesses, sold businesses. It was very different from the previous one where it was a bunch of guys out of university. This one was an experienced bunch of guys. Some of whom had come out of university the previous time around. One was actually a physics graduate from here in Clark. Still with us. In fact, all of the founders except one are still with us 10 years on, which is very much unique in this space. So we raised Series A, 6.3 million, started developing our first product, which was a tunable filter. And then right out here, that tells the VCs that tunable filter isn't right, the market isn't big enough. We were tracking the market, not technology, so we basically tracked the market, said it's not good enough. If we continue on this and we're successful, we won't make enough money. VCs want to make a lot of money. We can see a way we could make a return their money. I couldn't see a way I could get any upside given the size of the market. And so we switched then to this development of the wavelength selective switch. That was an interesting process, persuading your board and your investors that the money they spent so far is basically wasted. It's still, the prototypes are still sitting on the shelf back in the R&D lab. Everybody wants them sitting there. They're going to go to the powerhouse next week because they're part of an exhibition we're going to do on occasion. But we basically closed that down and started again around about here. We then developed this wavelength selective switch for about 18 months. We got to the stage where we had prototypes, pretty ropey prototypes to be honest. We used this LCOS technology that we basically invented. We own that intellectual property. And I remember we built the first one, we were taking it round to customers, around about here. Because what you really want to do before you raise your Series B is you want to have some traction. Just enough traction to the next set of investors say, yes, they've got to where they want to go, they've proved they can do this, they need some money now to fund the development and commercialisation. So this first round is usually about technology development, technology proving. Second round is about sort of really more engagement with customers. We built one of these and we were taking it around the States, and it was, you saw how big the current WSS is like this. This one was about this big. It had a PC built into it and it was enormous. And somebody stole it. We had one of these things, and some bastard stole it at Newark Airport. We found the suitcase that it was in, we never found what was inside the suitcase. This was what was on its way to Bell Labs for a test. So we actually had to then build the second. We had two LCOS at the time, one which is on the thing, one which is in the labs, which we didn't develop on. So we take one out of the lab, stop development, get it into a box and get it to customers. To get this customer verification, the idea was good before we could raise the money. Because this 6.3 million was starting to run out around here. We had about 3 or 6 months of the runway left before the next round in. You do burn through money. 6.3 sounds a lot, but it's not when you've got a team of 10 or 15 people, you're not paying external people to develop parts of the product for you. The old costs we were using, we paid $30,000 each for at the time, which is just like about 3 orders of magnitude more than we pay now. So it was an expensive business developing this product. Here we went for the Series B, we bought in Starfish. If everybody wants funding for VCs, I'll introduce you to Starfish. They're the only one of that model still standing. They're a great bunch of VCs. I love them to death. They really understand how to do stuff. And on the day that we got the money, we always have a good dinner. That's one of the nice things about raising money. On the day you close, you have a great dinner with all the investors. Everybody's really happy. That's the happiest day of an investor's life when they give you the money. The relationship with the investor is as good as it's going to get until you sell the company, make them lots of money. That in between is this trough of mismanaged expectations, where they expect lots of money quickly and you say, no, not yet, not yet, not yet. I went there around the other way, I turned that around and said, the day we went for that dinner, I had a glass or two of wine. I stood up and said, right, I'm going to tell you one thing now, I'm going to sell this company within a year. Usually when you get that sort of money, it's 2 to 3 years to maximise the value of the company. Use all your money up and make the company as valuable as you can for the maximum return. I wanted to sell the company as quickly as possible so that we could basically ride the growth of this market with a large partner. I knew that we needed to partner with a large company overseas. We didn't have market access. All our customers from Ghana from day one have been overseas. We need people who've got global reach. It's really hard to do that from Australia. A lot of people sit in front of us, not the heads yet, so we did the same. Basically looked for a partner we could sell to. And 6 months later, we signed a deal to sell the company to Optium, a company called Optium, which was a startup in the US. Optium was in the business of selling transceivers, basically lasers and receivers that are used in the systems. We sold the switching part. Our customer base was the same as theirs. I knew the management team there intimately, worked with their CEO back in JD's Uniphase days. He was the regional manager there. He was a total bastard. I swore I'd never work for him. But I finished up selling my company and directly reporting to him, which was really stupid. But he's a fantastic guy. He's just the hardest driving son of a that you're ever going to run across. He's about my size, that wide, an extra-Israeli seal, and he's just it takes no prisoners. Great guy, just what you need running a startup. So we sold to Optium. It was an interesting process to sell because At one time we had Optium, who were a private company, wanted to buy us, and we had a listed company. I'm not allowed to say who they are because it's confidential. There was a NASDAQ listed company who wanted to buy us. Optium were offering us shares in Optium, which had no value because they were a private company. It couldn't be sold by investors. There was just a share transaction. The listed company was offering us cash. And the investors go, oh, well, we like cash. We can take cash and we can then give some back to our investors. We can keep some for ourselves. So there's this incredible dynamic that built up between the management team who wanted to sell to Optium because we knew them, we trusted their management, we liked the way they saw the business, and some of the investors who wanted to sell to this other company that was listed and they could get their money out. Look, we, the management team, go, don't touch them, they're an awful company, we don't want to be working with those guys. We've worked with some of them before, we don't want to touch a large one. And right until about a week before we closed with Optium, there was still this incredible tension between the management and the staff of the company and some of the investors. We had to go on trips toward both potential buyers together, and it was quite a tense process at times when they are trying to pull you in one direction, and the management saying, we want to go this way. The investors own the company, so they had like 70% of the company shares, so they could have forced us to sell to this other company. We, the management, had 30% of the shares. But we also basically looked at what made the company valuable. It wasn't, a market position, something like he was good if the management team wasn't there, the IP wasn't with it. So in the end, we had to stare them down and say, we're not going to go with these guys who are NASDAQ listed company with cash. We're going to go with Optium. And if you sell us to there, we're out of it. We're going to take our money, we'll get the deal, and we'll walk. And at that point, it was literally that point that we could actually go and do the deal we wanted. So we sold to Optium. We were acquired by them Sunday in 2006, Sunday before IFC. We did very well. So we signed the deal well, and the plane came to IFC. And then at IFC, had a meeting with a bunch of investment bankers and decided on Thursday of IFC with the Optium management that we were going to go for the NASDAQ IPO. The plan was to do the IPO about 2 years out once we grown up. And the bank said, go now. Now's the time to go out there and raise money. So we did. We went and did an IPO on NASDAQ in 2006 and in October 2006. And this is where my story about leading research and the leading research comes in. My job in the IPO, I wasn't based in the US, so I didn't get involved in every day-to-day meeting with all the roadshow. My job was to look after the pretty picture on inside the front cover, because I sort of used to do quite a lot of graphic stuff in the company. And it's the only bit of colour in a what's called the S1, the listing document we have when we go out to sell shares in the IPO. Inside the front cover, you have a pretty picture with sort of, Optium is the leading supplier of optical subsystems to the telecommunications industry. That's what we wanted to say, the leading supplier. And for 3 months and about 80 hours of calls with lawyers and SEC people and God knows what else, my entire focus was to keep the word the leading, not a leading supplier. And we finished up being a leading supplier, not the, because no matter how many documents I produced about market share, about all of the research reports, none of it was enough to prove without a shadow of a doubt that we were the leading supplier, maybe a leading supplier. So that was a very painful and salutary process about how lawyers can just get in the way of having some fun. IPOs are great fun when you're not doing that sort of lawyering. Then in a couple of years after that, we merged with Finisar. Optium was in telecoms, Finisar was the biggest player in datacomms. We put the two together to create the largest player in the optical component space. And now I have to put this slide up. See, we are a market leader, not the market leader. Even though we're bigger than anybody else, we're only allowed to be paid. We're the #1 supplier, but we're not allowed to be the leader. So we make the transceivers, transponders that you use for connecting computers, for connecting optical communication systems, whatever. Focusing on high speed, so we don't have anything less than 2.5 gigs, we go all the way up to 100 gigs. 240 gig parallel transceiver is the latest, fastest thing we've got. both for storage networks and for optical transmission. And we are global. We've got 7,000 people. Over 6,000 of those are in Asia. We're actually an Asian company that doesn't know it. We have our own manufacturing plants in Ipoh in Malaysia and in Shanghai, 4,000 Ipoh, 2,000 Shanghai. There are only 300 people in the US. So it's a US headquartered company, but most of the company isn't there. We've got manufacturing plants in Korea, we've got manufacturing in Australia, we have no manufacturing in the US apart from some labs and so it's a really kind of strange company. It thinks itself, management is all US based, they're all US, they think themselves a US company, but we're really a global company. So we are turning over about $1 billion a year now, Finisar. It's a good company. Now down in Finisar, Australia, this is our mob in Waterloo. This is what used to be in Ghana. We do basically WSS, wavelength selective switches, design and manufacturing, which is optical, electronic, software, firmware, thermal, mechanical, everything. We do the optical assembly, although some of that is now done up in Shanghai. We have a group up in Shanghai doing that. We do the calibration and test of the modules down in Sydney. This is one of the WSS assembly. I'm going to ask Rebecca which one it is because she probably recognises it better than I do. But we basically are now the market lead in modems. We have revenues north of 100 million a year. I can't say exactly how much it is because this has been filmed, but later on we'll turn the camera off and tell you. We have global market share, we're number one, about 40% of the global market for WSS. And for the 2009-2010, we were growing at roughly 30% a quarter, which is a huge growth rate. And again, a bit like the index story, you go through this massive growth. Everybody really dies on their feet because you're working 12-hour days, you're working weekends. We were running 3 shifts, 5 days a week, 2 shifts at weekends. Is that right?
Too many shifts.
Too many shifts. It was ridiculous. Absolutely ridiculous. We went from, when we started, we moved to Waterloo 3 years ago, 3 years ago, we were 100 people then, and then we grew to nearly 400 people in a couple of years. It was just crazy, absolute madness. We're now down to around about 300 people because we're putting a lot of the optical sub-assemblies up in Shanghai. That's 200 people up in our factory in Shanghai working on that. So we got full factory, awful lot of engineers and PhDs. We're very degree heavy in the company. Early on it was because we had a lot of development work, then we needed degree level people in manufacturing, and now we're sort of back into the development phase of manufacturing, so that's degree level. But that's a fairly high number of engineers and PhDs that we've got. So that's sort of as the Finisar, that's the story of how you take VC money, turn it over, sell it to a company, sell it to an overseas company. Optim Finisar actually invested about $32 million into Australia in terms of the capital or the factory facilitation. So there's been a huge inflow of capital from Finisar as well, not just from the VCs, that's been fun enough. And we're still doing very successfully. But as in all of these things, I might get more when it gets to a certain size. Around about when we got to about 100 people, I decided it was time for me to take a step back. And as somebody who likes running large organisations with all the issues of HR and unions and all of that sort of stuff that is not my hot buttons, and I can focus on developing business, which is my hot button. Developing business, I'm not good at negotiating with unions. So basically I stepped back and with myself and with Steve Friskin, who's the founder of the company, we stepped back to try and create another startup because startups are fun. And this was the one we were doing inside Finisar. We created this group called the Optimal Instrumentation Group, or New Business Ventures as it was then. To do 3 things. To build new businesses based on Finisar's existing technology. So Finisar's got technologies the wazoo all over the world, all aimed at these high volume, low cost markets. Our view is how can we take that, repackage it and sell it for more? To pick up new opportunities and technologies from anywhere in the world, basically to reach out to people and find technologies we can bring into Finosar. And we sort of do that through M&A and a range of other M&A merchant acquisitions. And then to create linkages to R&D groups worldwide. CUDOS is one of those groups that we link into. We link into other groups as well. To allow us to basically grow the company beyond just this one thing. We've done a number of things. We've got some advanced passive components that have been developed by the team in Shanghai that we identified in Sydney. A component developed by Shanghai will be packaged in Fremont in California. It'll then go into module assembly in Israel and finally into line cast back in Shanghai. So this product will be developed with us in Shanghai and then circle the world and finish up back in the manufacturing line in Shanghai. We had a thing in biophotonics for a while. I had a group looking at OCT, some of you remember Nader. Nader was working with me for a while. We spent about a year, had a team of about 4 people looking at opportunities in OCT, optical image tomography. And then we had to close that down because the market wasn't where we needed it to be. So we spent $1 million to try and get into that market, close that down because there wasn't the opportunity size of the amount of money it would take to get there. Something I still love to do. I'm really fascinated by the whole OCT side of things. I think there is a market there, but I couldn't get there from where we are now with the money that we need. The one that has that I'm going to talk about just briefly and finally is the wave shaper. Now, most of you have seen the wave shaper sitting on the benches here at CUDOS. I know that it came out of there. The way that this sort of works is programmable test instrumentation. We had a bunch of IP sitting in Finosar of how you can drive and ideas of how you can drive our WSS to do different things. We've got a bunch of patents that say you can create different attenuations and things like that. So we threw one of these things at in fairly early stage of development. These things weren't packaged properly at the time. Through to Ben and to Michael Rowlands and said, go have some fun, look at some applications. What can you do with this technology if you can create all of these weird patterns? And you can still continue networking. And then we did a technology transfer out of the university, which basically meant I hired Michael and said, come to work for me. And we're going to build a business based on what you've learned playing around with this technology, which is what we did. We created the first wave shaper back in 2008. It was 3 years ago now. I actually remember it because I actually built it myself. It was great fun to actually get back and start playing things together. I had to ask somebody how optical connectors work because when I was doing my research on how connectors, it was all just splicing. Actually, something predated splicing. But basically, built the first wave shaper. That's the non-flat thin one that's still floating around somewhere. And we started selling these things. We sold $1 million in the first year. We then had to do a redesign to get the thing manufacturable, which is why that looks like that long thin thing we used to have. We did, so that should be year 2. We did $4 million in the second year. And we're trying to get to around about $8 million of revenue this year. We're halfway through the year and we're at about 3 and a bit. So our growth trajectory might just get there, not quite sure. So basically from some research applications, but taking our WSS and playing around with it, in 3 years we've generated about $30 million of revenue. Again, mostly for export. We do sell some of these in Australia, but not many. We pretty much give them away here. We sell them way less than the else. Chris, stop laughing. You just don't value software. So the funding for this basically was to provide the initial salary for Michael. I was already employed looking, I got an agreement to do director of new business development, so I had this role to look across the company. Steve was the CTO, so he's really important. So we had to get the company to agree to fund Michael, and I took some spare cash to build the first couple of wave shapers. After that, wave shapers have been profitable from day one, and cash flow positive because of the way that you've set up the business. It's been a very good business at Finosar. And this rate of growth has allowed us to basically expand the team. I've now got 10 people in the team, 11 people, 9 have got PhDs. It really is a very, very high-powered team. I can do that. We can do an awful lot of really interesting things. We've got some great products coming up behind this, which we'll be able to talk about in about a year or so. We now have not just the wave shape that you have here, the C-band, but L-band. We've got a new C+L that covers about 9 terahertz. We've got a single polarization one we just shipped to the first customer. And there's some other versions of that, all those things in the pipeline as well. Plus, there's some really cute technology that's coming through, pulling bits out of other parts of the FSR, taking into instrumentation. Target there is to hit 25 million within 3 years. We're at 8 million this year. We've got 2 more years to go to get to 25 million a year for that little startup. Okay, that's how we've done 3 different startups, all in the sort of optics space. We've got 5 minutes or so for questions, and I'll take any questions about anything from anybody except what my margins are going to be. Chris.
Right back to the start, to the first startup you're talking about, you said that you pitched the technology to 20 different companies and they all turned you down.
Yeah.
What were you offering to them? Were you offering people or patents? Or
We were
equipment?
offering sort of basically access to the technology base, which was, there was some patents, there was a lot of know-how, there was, basically we wanted to get this technology out, support from the group to get the technology to train people in it. It was basically, I wanted to keep running the research group at the time. I didn't plan to do a startup.
So you're going to, with the know-how, you're going to actually send them people to work for them?
Either
Or
that,
just
or they
make
send
it
people in to learn, or it was whatever we could get anybody to agree to. At least one of the companies that we pitched to subsequently went out and built its own fibre grading capability 3 years later. Once we'd been successful, they went and did it themselves.
Yeah.
But at the time, there was nobody really at all was interested in this. I didn't talk about some of the other funding things we tried to do to get that funded, but basically there wasn't any VC money around at the time in Australia. Those of us with grey hair, we were in the Australian Technology Group as precursor to these early stage VCs. We pitched to them, they were interested. And there was basically no support for this sort of thing. Depending on how we go on other questions, we can talk later about some of the other things that we tried to do, but I think I can talk about this for hours. Yeah.
2. The first one, how do you accurately assess the marketplace for when you're looking products? And the second one, how do you manage customer and supplier variability?
That's 3 questions there, because there's 3 separate things. The market, you can go and buy research reports and they'll tell you what the research guys know. What they don't tell you is what's going to happen 5 years out. Okay, so if you went and got a research report sort of back here, most of the reports said it's going to go back up like this. It's just a temporary dip, it's all going to be fine in the future, life is going to be great. They didn't none of the reports at that time picked up on the fact it was going to be reconfigurable. They all said things like polarization, moment dispersion compensation, CD compensation are going to be the big next things, neither of which happened in any real size.
So how did you figure it out?
Because I've been doing this for a long time, I got really lucky.
Okay. So just talk to you, right?
I put a lot of it down to luck, but also just the fact that we've been in the market, we've been sort of looking. The index was doing like fixed versions of this, so I've talked to everybody for the last 10 years about where it's going. It felt like that's where it was going. There were other companies called Innovance in Canada. I did a bit of VC work in between the 2 companies. I worked with a couple of Innovance in Canada who were doing reconfigurable networks that I thought, this is so cool, this has got to be the way it's going to go. As it turns out, they were 10 years too early. What they were doing there is almost what people can do now. So that's how I did the market. It's still the same. You read what you can, and you just got to know and extrapolate. Just use a lot of else. For managing customers, that's a tricky one because the customer ultimately is king. They can cancel orders, they can load the orders up high. You can through this first part of it. Basically, we had an issue where a large Chinese customer of ours who'd been steadily buying very nice large quantities just suddenly said, we don't need any more for 6 months. They're supposed to give us 3 months notice and then sort of minor changes, and they said suddenly one day, nothing for 6 months. We go, holy shit, that's like, you know, $10 million a quarter business that just walked out the door. How do you manage that sort of thing? It's very hard. All you can do is to try and diversify your customer base. Get as many customers as you can manage, which is not the same as many customers as possible. As many customers as you can reasonably manage so that you're not all pointing to one large customer who can just pull a plug and half your revenue. Last one is suppliers. That's really a very complicated question, which is why we make supply chain managers so much. It's the trick from a startup perspective is that you choose your startup suppliers who may not necessarily be your suppliers in volume. Okay, you choose your startup suppliers because A, they'll work with you. As a startup, you can't usually go to people and say, I'm going to buy 100,000 of these for you next year. Whereas Finisar can go, I'm going to buy 100,000 for you next year. And they'll believe Finisar. They won't believe 3 man 10, 3 person 10. It's just starting out. So you need people who will do the small volumes, who are not the same people who will do 100,000 for you, usually. There's usually disparity. So find somebody who will work with you for the start, for the early prototypes, and then hire a supply chain manager to manage that transition into a volume. There's, you know, supply chain managers, good ones are not gold dust. Bad ones are easy to find, and they cost you a lot of money because they do the wrong thing, too many of them. Don't centralise purchasing. That's just a tip. Yeah.
You got another startup in you,
Oh,
if so, how would it be different now in the current business environment?
That's a very interesting question. I still believe that there is an opportunity to differentiate in hardware. So I still think hardware is a differentiator. I don't like doing iPhone apps. I can't see how to really monetize an app unless you're outrageously successful. But I can see how to monetize to a state of a sustainable company. To make one app that's good and you follow up really hard. A sustainable company, I can see how to do with hardware. If I was doing it again, I would do the VC funding. I've never, apart from a little bit into Bengala, used my own money in my startups. It's just a rule I have. I don't put my money, my hope on the line. There's no stress without having buy from your ex-wife, as the case may be, beating up on you because mortgage has been called in by your bankers. So I don't do that, never have done, and never will do that. So would I do another one? I don't know. Some days I think I'm going to get out into a small company again. Other days it's just so much fun. I just enjoying what I'm doing. I've been there for 10 years. I used to say that people knew me early might say, I never wanted to work for a company that gives long service leave. I'm now eligible for long service leave. I've got 2 months of long service leave due next year. And this is not so bad after all. So I don't know, I get a little bit old, I guess. If the right opportunity comes along, I'd still do it, but it has to be the right one.
So you have kind of a year period, or I guess 2 years before you got your Series A funding.
Yeah.
And developing this stuff is a lot capital intensive. So where did you come up with the money for that point?
That's a good question. The trick, there's a couple of things that we did that we could do at the time. One is that everybody who was involved with this got a layoff payment from their previous company when they got closed down. So they basically all had enough money to live on for a year or so while we raised the money. A couple of the guys have made out very well, and they actually put about $500,000 into the company on day one to buy capital. And we basically bought all of our capital at about 5 cents in the dollar from all of the close downs that happened. We bought a lot from Nortel type technologies when they went belly up. We bought a bunch from JDS Interface when they went belly up 18 months later. And that gave us a capital base, some of which we're still using. We're still using that medic sealing system that we bought way back then. Unfortunately, we've now got another lot of them. But you know, those sort of things we're still using. We're still using some of the testing that we bought because we ship. We don't buy any new test kits still. We still buy second-hand test kits.
So by the time you got to your Series A, your product was only partially developed then as well?
It was very, very partially developed. It was enough to make an independent VC believe in something. Because the VCs were not optics people. The VCs funded us because we've been successful and we knew the market. And they trusted us and we said, this is what we're going to build. We don't know it's the right thing, but this is what we're going to build. If we need to change it, we will. So right up front we said, we may got it wrong. But trust us because we've done this before, we've made these changes in our companies, we've gone where the opportunity is. And they basically funded myself and Steve Friskin's judgment that we would find a way through the mess. It's almost a truism that all successful companies change what they're doing at least once in their life. When we did Index, we started off saying, the great thing about fibre brand ratings is you have these really precise, narrow filters. And then 92% of our business was really broad filters for game plan, which was not something we had on the business plan when we started. For the first 2 years, it just didn't exist in the business. So that was an example of the sort of change that you have to. You can't be wedded to one sort of idea. You've got to go where the market is, moderated by your belief in what you can do. You must just custody it says, you've got to do this for me right now. They could be wrong. You've got to filter that. The customer's doesn't always know where they're going. We had customers with tunable fields said, yeah, we're going to want loads of these, and they never bought any of them. They still haven't bought any 10 years later.
So Dragos Uniphase manufactured back in the late 90s, and I think you're now moving away from manufacturing. That's all Malaysia and Shanghai. It's mainly R&D. Is that correct? And what does that mean for your evolution and your future?
Well, we will continue to maintain manufacturing in Sydney. We have low volume, high value add production, specials production, which you can't do. Chinese manufacturing is very different from Australian manufacturing in many ways. We see all of these high volume Chinese lines. What they do is they atomize the process. They break the manufacturing process down into individual steps, which takes about half a day to train somebody to do each of those individual steps. We notice we have sort of very high volume manufacturing lines in Shanghai. This is how it works. You get people straight out of college, you train them for a day or two to do this one process very precisely, and you break the process up into lots of little steps along production. What we do generally isn't amenable to that. It's much more holistic. We can break it down to the point that there's still a lot of training. It takes weeks to train someone to build the optics for WSS. Even with all the automation we put around it, it still is a painful process training. So it's not an instant transfer across of everything. The other thing is intellectual property. We are paranoid about our intellectual property. Our intellectual property is not in our optical design, although there is some in there. Our intellectual property is in our manufacturing software. Our key intellectual property is our manufacturing software. It sounds really strange, but basically the process whereby you take this little optical unit that sort of works and turn it into something that works perfectly. The calibration process is the secret sauce behind it. It's not the fact that we've got a nice optical design, although that's important. It's the fact that we can take this crappy little piece of optics, which has been built to the best that we can, with certain constraints, and basically make it zero in on the performance that we need through software. That's the secret sauce. That bit of it will never go outside Australia, it will never leave the factories. It doesn't even leave the machine to its on. It doesn't go to the server, back up, it gets back up. So it's a totally different thing. We've had people who have tried to access our technology, we know that. We know that people who try and copy what we do. We are totally paranoid about that, so we will always have that bit of manufacturing here in Australia. And we need to grow more value add, which is part of what the Wave Shaper activity is about. It's about growing the value add part of manufacturing. You can afford to manufacture things that sell for $25,000 to $40,000 in Australia with a lot of know-how. You can't manufacture stuff easily here for sort of $500 with just a lot of touch time. It's what's the right sort of manufacturing to do. I passionately believe we have to manufacture here if we're going to keep a real economy other than just being a beach or a sand. Yeah.
So what is more important in startup, the IP or the know-how?
The market. That's the most important thing in startup. We went into it with no IP. We had a lot of know-how from previous slide from our history to date, but we have everything we've done since then, we've developed since we've created the company. So I don't believe that you need to take, Index was a taking technology out, but I've been looking for something for ages we could push out the research group. There wasn't anything that suited. Fibre-grade was the first thing I was trying to push out, then I had to take it myself. But that's because I believe there's a market for it. And I sort of proved that to myself when I got that first order, $30,000 order. We proved that if somebody wanted to buy this stuff, that was enough to sort of flip it over the edge. So it's all about the market. That's the thing that matters most in this market. It's whether you can build and sell something that some people pay for.
So let me reformulate that. Within Ghana, you had a startup with no intellectual property, but you build it up and then you own it.
Yep.
Can you start a startup with an idea that is already out in the open, there is a market, but you do not hold the IP?
No. That's a very dangerous thing to do. You can, if there's a problem that you're solving, which you can solve in a way that other people don't have any patents or control over, then you have an opportunity. If you're trying to use the same technique to solve that problem that your competitors are, you don't be a problem in deep shit with a patent.
Yes, okay, but if there is no patent.
If there's no patents, then you can't hand it over if the know-how's out there.
Yeah.
Then it's just purely a market, it's time to market. You can get IP in manufacturing. Now, Finisar has 1,027 patents. We have 8 of those in the WSS. And yet we are more than 10% of their global revenue. So we have a very small type, but very focused patent group, which we are going to be relying on going forward. We took a very proactive approach to patenting. There's a lot of sort of knowledge in how to patent properly as well. It's not just throw the first patent out. It's all about a strategic patenting approach where you have your core IP and then you build up other patents around it and then you build up another set of patents around that. Basically ring fencing this core IP. You try and create a bunch of things. People have to knock that set of defences down to get the next one to build a tackle the core IP. And it always comes down to something. In Index we have patent files in Ghana, where there's patent files going all around the place. It's a fact of life once a business becomes interesting. And by interest, it's got to be $20, $30 million a year business. Nobody's going to sue you less than that. It costs too much money, they won't make any money. So if you want to grow a business $10 million a year, and that's all you want, you don't really have to worry about patents. You're not going to do enough to build a big cost. But no, that's not formal advice, that's just my personal opinion. So it's being filmed, so I don't talk this.
So can we turn the camera off now?
Okay, I think we sort of pretty much run over time. Any last questions? No? Okay, well in 2 weeks' time, who have we got in 2 weeks' time?